Okay.
Wonderful, Al. Thank you. That was an amazing video. Let me put that one back up.
Okay.
Yeah, and again, let me know if you need me to switch slide shares for you.
Okay, we finished this one. Okay. Now the invisible wall. I was working in a factory, a polymer factory, and they made polypropylene and polycarbonate sheets, and under certain conditions there were very high voltages because they was acting as Van de Graaff generators. And one day there was a cloud drifting. Let's see. Okay, you see it on the right lower place. So you see the cloud, but the action where the spikes were, they were between 18 and 20 meters. The electricity was built up here, but the invisible wall was not near the extruders. So I don't know how to explain everything, but what I can tell you that it is real, and it shows that it's possible to stop heavy objects. In the movie, on the end, you will see a trajectory, and which is made from two half circles, and where there's the connection of the circles, there's a change in the field, and this creates an invisible wall. So what is interesting in this video, that if you go the opposite direction, the levitator will go faster at that point. Okay. Now, according to Coulomb's law, the voltage required to stop a human body with the height of 186 and the mass of 76 kilograms, you must exceed 3.5 megavolts. Okay. Okay, I will show now the movie. Tim, can you show the movie?
The invisible wall. For over 20 years, I worked as an engineer at a plastic factory in northern Israel. Repairs, electricity, programming, nothing prepared me for what happened one unforgettable day. It started with a phone call from Musa, one of the machine operators. His voice shook. "You have to come now," he said. "There's an invisible wall. I can't get to the polypropylene area. Minutes later, I was racing to the factory on my scooter. When I arrived, Musa stood there pale and trembling. Together we walked to the production line, and then it hit me too. Something was blocking me, an invisible and strong force, like a wall of flexible cushion. pushed me back. I wasn't imagining it. My full body simply couldn't move forward. Then just as suddenly as it appeared, the wall vanished as if nothing had happened. 2 years later, it's happened again. Same place, same eerie force. A blazing hot summer afternoon. Before and after the incidents, we saw strange signs. Thin, sharp sparks jumping beneath the plastic sheets. No discharge to the ground. The air was dry. The static voltage climbed to unimaginable levels. Millions of volts. After I retired, I couldn't let it go. I built devices, experimented with high voltage, and somehow I cracked something. I made objects levitate, breaking rules physics swore were unbreakable. Was the wall an accident? Or was it something bigger? Something waiting to be discovered?
Al, thank you again. That was amazing. Okay, let me take the video out. Should I put your slideshow back up, sir?
Okay. 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 Okay, I want to give here a more technical explanation. The horizontal spikes measured between 18 and 20 meters. The spikes were below the corrugated polycarbonate sheet. The spikes were very thin. The height between the ground and below the plate is about 1.2 meter. There was never a discharge to the ground. The wall was not near where the spikes were produced. I explained this before. There was no sensation of high voltage when I was in this invisible wall, such as hair standing or sparks or things like that. In the time that I worked there, it happened only 2 times, and I was working there more than 20 years. It is in my belief that there was a very high charge air and invisible charge cloud. Within the cloud, there were 2 different potentials that created the wall. Conclusion: with low humidity of 3000 volts per millimeter, over 20 meter translates to 60 million volts. According to Colin Ver's square law, around 3.5 megavolts is required to generate this force to stop a body of 76 kilogram. Okay. The significance of the invisible wall lies in its ability to influence heavy objects. However, there is no evidence or theoretical basis suggesting that the Biefeld-Brown effect can function in space. Convincing organizations to invest in a costly space experiment without proof is at best extremely difficult. Testing in a vacuum chamber is also problematic due to interference from the chamber walls. Even in NASA, where they have a very large vacuum chamber, the walls can interfere with the experiment. The best possible place on Earth to make the high voltage experiment is where humidity is very low, no wind. Still, I believe that one day we will harness electrostatics in space for propulsion and protection. We simply need to discover the exception within the existing scientific principles. Okay.